So I'm going to design a circuit 3 times actually. The first time I'm designing using a ROM, then I'm going to use PLA, then I'm going to use decoders. So let me write the combination for this. You could have 0, 0, 0, 0. Let's write all the combinations. 0, 0, 0, 1. 0, 0, 1, 0. 0, 0, 1, 1. 0, 1, 0, 0. 0, 1, 0, 1. 0, 1, 1, 0. 0, 1, 1, 1. That's 8 now. 8 sets here. That's the 7. So the next one's 8. 1, 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. I don't even know what 866 is. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. 1, 1, 1, 1. These are all the combinations. So I guess I made mine too long here. I don't need it to be that long. Okay. F is going to be 1 when what? When W is 0, X is 0, Y is 0. Right here. These two. W 0, X is 0, Y is 0. W is going to be, F is going to be 1 when X is 1, X is 1, Y is 0, Z is 1. 1, 0, 1. That's this one. 1, 0, 1. Where's the other one? 1, 0, 1. Right here. F is going to be 1 when W is 0 and Z is 1. W is 0, Z is 1. That's this one. That's this one. That's this one. And that's this one. Am I seeing anything else? So the rest will be zeros. I think I'm good. G is going to be 1 when what? When W is 1, that's this group down here. Y is 0, Z is 1. Y is 0, Z is 1. Y is 0, Z is 1. That's right here. Y is 0, Z is 1. That's this one. G is going to be 1 when X is 0, Y is 0. X is 0, Y is 0. That's this one. That's this one. That's this one. That's this one. The rest will be zeros. Up, I'm a little bit off crooked here. Now, again, if I'm going to design this using my ROM, that's the first option. Design, implement this using a ROM. So here's part A. ROM. I don't know if I can fit that on this page. I could probably. W. Before I do that, let's count. Do I have enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, I'm okay. That's the W bar. X X bar Y Y bar Z I can't imagine doing this job for a living for me. I don't know. I'm not that type. And now we're going to list all the combinations. So I need to do 16 lines. That's with the ROM. You're going to identify every one of them. That's 1, 2, 3, 4, 5, 6, 7, 8. I'm getting nervous now, space-wise. 9. 10. 11. 12. 13. 14. 15. Just enough. 16. And now I gotta label them. 0, 0, 0, 0. 0, 0, 0, 1. 0, 0, 1, 0. 0, 0, 1, 1. That's the first 4. 0, 1. 0, 0. 0, 1. 0, 1. 0, 1. 1, 0. 0, 1. 1, 1. Now I need 4 more. 1. This one you go up line. 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1. Where's the 0? 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. 1, 1, 1, 1. These are all the combinations. Now I'm going to have 1 for F and 1 for G. His is F. And this is G. F and G. Notice, let's look at F. F is going to be 1 with a 0, and G is going to be 1 as 0. F is going to be 1, G is going to be 1. At 1, I mean. They're both 0 at 2. At 3, F is 1. At 5, F is 1. At 7, F is 1. 8, 9, 10. Where's 1? At 12? 1, 1, 0, 0. Where's 1, 1, 0, 0? I think that down here. Is that it? Is that it? 1, 1, 0, 0.
1, 1, 0, 1, right?
Is that 1, 1, 0, 1 or 1, 1, 0? 1, 1. Yep, 0, 1. Thank you. You need glasses.
Can we just do it for those functions when it is on?
That's what I'm connecting. No, you gotta connect them like this, the whole thing. That's how they want to ship to them. 1, 1, 0, 1. And G, I did the first two. I got 3 more, right? 8. Where's the 8? 1, 0, 0, 0. 0. I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This will make my life easy. It's going to be at 0, at 1, at 8. There's 8. At 9. 8, 4, and 1. What's 8, 4, and 1? 13. And that's your ROM now. Design. The second part of the question, can you design this with PLA? That means not PL. If it says PL, that's programmable array logic. We'll be using this board. PLA, we're going to make a K-map for each one and see if we can find some matching ones. And it says we only have for that, how many gates?
4.
With 4 terms. Okay, 4 terms. So we're going to try to find some matching ones. PLA. So let's take this function. Same one, we're going to use part B here. We're going to design the same one using PLA. So I got to do a K-map for each one. I got to do one for F, one for G, and see if I can find the matching ones, and hopefully I can group them in 4 terms. I'm really trying to be nice and neat, but usually it doesn't happen. That's good enough. There we go. I need another one here. Okay. What are W, X, Y, and Z we using? W, X, Y, Z. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. W, X, Y, and Z. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Let's look at F here. Has a value 1, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 0, 0, 0. 0100. That's F. And let's look at G. G has a value 1100, 0000, 1100, 0100. I see one term matching, unless I copied something wrong. I see one. See this one? That's one. Just double check 1101, 0101, 0101, 0000, 0100. Okay. 1100. 4 and 2, 6. Yep. 2, 2 and 4. 2, 3, 4, 5, 6. 2, 2 and 4. Okay. I got it. I see this one. That's two of them. I see this one. And there's the 4. Right? So the top one here, that's common to both of them. This one here, up and down, that's what? W bar, X bar, and Y bar, right? And that's the same for G. W bar, X bar, Y bar. The other one that's common to both of them is this one. I'll take it by itself. And that'll be what? WX, Y bar, Z. WX, Y bar, Z. Now this side has one more here, and that's what? These 4, and that's W bar, Z, and this one has one more, and that's what? W, X bar, Y bar. 1, 2, 3, 4. It's a design using PLA 4 terms. This is my 4 terms. So when I build them, this is a little bit different, shorter space here. This is W. Next one is X and X bar. Next one is Y. And the last one is Z. So the first one, we're going to have 4 lines coming out of it. This is one. This is another one. I'm not sure why the marker's dying here. This is another one. And one more. So the first gate is going to be W bar, X bar, Y bar, W bar, X bar, Y bar. And that's really going to both of these. I'll put F and G here. F and G. That gate is common to both. It's going here and it's going here. The next one is what? W, X, Y bar, and Z. W, X, Y bar, Z, and that's also common to both. And I have one more W, X, Y. Oh, wait a minute. These are the labels. Now I'm looking at this as one of the gates. These are the labels of this. It's W bar, Z. This is W bar and Z, and that's only going to where? To F. And I have one which is W, X bar, Y bar, W, X bar, Y bar, and that's only going to G. And now we just designed the same circuit using PLA. Now the third part of the problem is designing that using decoder, 2x4 decoder. But the decoder we're going to use, there's the schematic for it. Same one. So we're going to redesign that using a decoder. And the decoder we're using is this picture, this schematic. It has 2 chip enables. I don't know if you can see it. Enable 0 or enable 1 has to be low for it to be on. Enable 2 has to be high. So this has to be 0 and this has to be 1. When these guys, if we have here 0, 0, that says this one is high. 0, 1, pin 1 is high. 1, 0, pin 2 is high. 1, 1, this is high. If these guys are not, if pin number 1 is actually high, it doesn't matter what pin number 2, nothing happens. This one is dead. Or if pin number 2 is low, it doesn't matter what this one is. This is dead. So for this to be on, this has to be 1 and this has to be 0. Otherwise, this will not be on. Doesn't matter. So when I design them, I got to make sure this has a 1 on it, this has a 0. The problem is I have 16 and there's only, this is 2x4. But it says we have as many as you want. We have available as many of the decoders described below as are needed, plus 2 8 input OR gates. 2 8 input OR gates. So design that. Well, let me make a 2x16 using this one. So I'm actually going to need 4 of them, or 5. So I'm going to make a 2x16 first. 4x16 out of 2x4 decoder. That's my first job there. So where's my graph paper? Here we go. I'm going to make 4 of them. I'll do this. This is 1. I might have made them too long, I think. A little bit too big there. Maybe I might have to shrink one of them. A little bit exaggerated because I hate it when I'm squished. So that's the first one. That's a 2x4 decoder. Let's do this. We'll put another one here. Another 2x4. Another, how tall is this one? About, can't even see the numbers on this. We'll just do like a little bit. There's 4 of them. And this is the 4th one. So each one of these has 2 inputs and 4 outputs. I want that to be pin 0 really. This is 1, this is 2, this is 3. I want this to be 4 somehow. 5, 6, 7. I want that to be equivalent to pin 8, 9, 10, 11. And I want the last one to be the 12, 13, 14, and 15. Well, I need another one here to turn these guys on. This is, again, 2x4 decoder. Every one of them. 2x4 decoder. 2x4. 2x4. We have lots of them. And 2x4 decoder. Remember the way this has 4 outputs here. 1, 2, 3, 4. It has 2 inputs. For this to be on, we said enable 1 has to be 0, and enable 2 has to be VCC. So this is enable 0. Enable 1, I'm sorry, not 0. I'm going to attach it to the ground. That's enable 1. It requires a low voltage to be on. And enable 2 has to be VCC. Enable 2. And I have 2 inputs. Now remember, I want to implement this function. So I'm going to use WX as, W is the most significant one here. I'll put it on the top. That's the most significant. X is this. So when I have 0, 0, that's really the first 4. I want this one to be on. Well, when I put 0, 0, what's going to happen? This one is going to be high. The rest will be off. So I need to make sure, since this is high, this is actually going to be my enable for the other gate. Because it's going to go high. That's enable 2 here for this gate. And I'm going to make sure enable 1 is always low for this, because it has to be a 0 for it to be on. So when you put 0, 0, this is high. So this is high, that 0 is going to force this one to be on. What are you going to attach this, Y and Z? So when 0, 0, 0, 0, this one is on. When these guys 0, 0, you're going to have that output. this will be high. When you have 0, 0, 0, 1, this one is on, that one is high. When you have 0, 0, 1, 0, this one is high. When you have 0, 0, 1, 1, that one is high. I want this one to be on for the second group when my input is what? 0, 1. So that's my chip enable to this one. And again, my chip enable for this is going to be similar to the other one. This is actually going to be high. This is my enable 2. Enable 1 is going to be ground. And again, Y and Z here. When you have 0, 1, 0, 1, that's 0, this is off. 0, 1, this one is on. So 0, 1, 0, 0. What's 0, 1, 0, 0? 0, 1, 0, 0. That's 4. This is high. 0, 1, 0, 1. That's 5. This one high. 0, 1, 1, 0. 6. That's high. 0, 1, 1, 1. That's high.
So the two on the second segment, the top two correspond to the top, the bottom two correspond to the bottom.
Which top two, bottom
0,
two?
1 corresponds to Y.
This one?
On any of the three right there, the top two outputs, 4 and 5, for instance, correspond to Y. 6, 7 correspond to Z.
Here?
Yes.
No. Ideally, a 4 by 6, you want, a 4 by 16, when you have 0, 0, 0, 0, you want pin 1. If you have 4 by 16, you want pin 1 to be high. When you have 0, 0, 0, 1, if you have a decoder, that says pin 1 is high. 0, 0, 1, 0, that's pin 2, 3, 4, 5, 6. I'm trying to simulate that. And by doing that, I'm attaching Y and Z to both of them. All these guys will have Y and Z for input. So when you put in, for example, 0, 1, 0, 0, Y and Z both going to be 0. So if this guy was on, this would be high, this would be high, this would be high, and that would be high. The question, I only want one of them to be on. And that's what controlled by the first two, 0, 1. When you put 0, 1, this pin is actually high, which turns that one on. These guys will be off. I don't know if that answers your question. So now the next one, I'm going to take this one, and that's my chip enable for the third one. And again, that's my enable 2. Enable 1 has to be 0 for all the time. That's why it's actually attaching it to ground. So enable 1 has to be grounded. So when I put now 1, 0, that forces this one to be on, this one off, and the bottom one off. And the last one, when I put 1, 1 here, this one is going to be high. And that's going to make sure the bottom one is on. That's enable 2. This is enable 1. And again, Y and Z. So this one actually, based on X and Y, I can decide which one of these 4 is going to be on. There's 4 of them. Based on X and Y here, what do you put for X and Y? If you put 0, 0, the top one is on. If you put 0, 1, this one is on. If you put 1, 0, this one is on. 1, 1, this one is on. So now we're going to design this, and you said you have 2 OR gates. So one of them is going to be 4. Each one has 8 inputs, according to that problem there. This is F. And this is G. Each one has 8 inputs. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's look at F. F is going to be 1 where, according to this one? At 0, at 1, 3, 5, 7. And down here, 13. So 0, 1, 3, 5, 7, 13. See it? 0, 1, 3, 5, 7, 13. Let's attach to that pin 0, 1, 3, 5, 7, 13. I have 2 more pins left here. What do you do with them? You can ground them. Because if you have an OR gate with 0 going to it, it doesn't change the other one. So when one of these guys is high, F is high. Pin G is going to be 1 at 0, 1, 8, 9, and 13. 0, 1, 8, 9, 13. So I have 3 more left, and those will be grounded. And now I can have F and G. So you run the wires from 0, from 1, 3 to this. You run these wires again to this, and that's your design. If you don't like grounding, you can attach the 1 or the 0 to 2 of these. Doesn't matter. You can attach the 1 to 2 of them till all these are taken. But if you ground them too, that's fine. And now that's my design using a 2x4 decoder with all the pieces connected.